Here's a simple experiment you can do at home. Take a piece of paper, prick it with a sharp implement like a pencil or a needle, and then shine a light through the hole. And on the other side of the hole you shine a light on your hand or another piece of paper, and what you get is some kind of pattern or of rings or such. And you might say, why is that? And the answer is that that hole forms a geometry, and any light that is going through that hole is now constrained. Since the paper is opaque, the shape, or the ghost if you like, of the light through the hole is such that it's squeezed into that hole. It's blocked by the opaque material, so it's zeroed if you like by the opaque material, and now we've got this pinched ghost shape. And the pinched ghost shape, if we were to perform measurements on that, that would give us different properties from having an unpinched shape, because shape determines all properties. There's no hidden variables, so you change the shape of the system and you change the properties, which is why light going through a hole has a different diffraction pattern than light going unimpeded. Now, all of the constraints in the system determine the legal shapes of that system, and all constraints have some kind of physical origin. So, for example, our room with its walls to stop the ghosts getting out, all of those walls have to be made of some kind of matter that is opaque, that is tangible, can block ghosts, is made of elements, is made of concrete, is made of steel. Now this is the problem, is that these constraints determine what geometries are legal, but the constraints themselves are made of physical matter. And the constraints, they determine the geometry, they are not determined by the geometry. So the constraints are outside of quantum mechanics, if you like. They tell you where to begin in quantum mechanics. They tell you what's happening in the arena, and then the ghost kind of fills in the details. And this is the deficiency of quantum mechanics, because quantum mechanics says that there's no variables outside the system, but the constraints themselves are variables, and the constraints are made of physical matter. And the ghost, if you like, since it doesn't describe the constraints, it is defined or permitted by the constraints. This means that there's physical material with a state leading to a constraint that is outside of the description of the quantum mechanics. So this is a deficiency of quantum mechanics. Quantum mechanics cannot describe its own constraints, which are formed with physical objects. Since quantum mechanics can therefore, since every quantum mechanical scenario has material that is outside of its own description, outside of the properties of the ghost, it means that quantum mechanics is not a theory of everything. And so the notion that everything is a property of a system is false. And I, as a student 20 years ago, studying theoretical physics, I remember I studied this, but at the time I didn't understand quantum mechanics in the simple terms that I do today. It actually takes an effort to understand something on simple terms rather than using the complex maths. When you use the complex maths, it detaches you from the fundamentals, And the fundamental of quantum mechanics is that it's deficient. So trusting too much in the mathematics and confusing theory with this metaphysical notion of truth, I believe that most physicists, quantum mechanicians, they've made the mistake of trying to explain metaphysical truth in terms of quantum mechanics. So they look at this deficiency and they say, well, we need this philosophy called the quantum measurement problem. And if we have this philosophy of the quantum measurement problem and we solve it, then at last we can understand quantum mechanics and understand where it's going wrong and how to physicalize these constraints. But when you understand that the constraints are a deficiency, quantum mechanics doesn't solve everything. It's not a theory of everything. Every sub-theory of quantum mechanics, every flavor of quantum mechanics has this same limitation. Then really there is no quantum theory of measurement. You just have to accept that it doesn't do everything. It's a useful tool, but it's not metaphysical truth. It's not the mind of God. It's not perfection. It's not the ultimate theory. It's just a theory. That's a good description of matter, but it has its limitations. And the limitations are now analysing its own constraints of measurement. Thank you very much.